Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. I welcome you to our next lesson concerning the change of subject of the formula. In our previous lessons, we were looking at how we change the subject of linear equations. And now, in this lesson, we shall be looking at how we change the subject of formula having nonlinear equations. Otherwise, what are nonlinear equations? These are equations whose variables are nonlinear. And the same, actually, the variables being nonlinear means they are raised to certain powers more than 1, because linear equations are having variables raised to 1 as their powers. So in nonlinear equations, we expect to deal with formula having variables with powers more than 1. That's what we mean by nonlinear. So the same procedure is followed, except that we have to be very careful with the manipulation of these terms in the equation, since they have some powers. So we shall consider two cases, that is, equations with higher powers and equations with fractional powers. So we shall start with case 1, where we have equations with higher powers. Our first example is, given that A equals to L squared plus B squared. They want us to make L the subject of the formula. So this is what we want to make the subject, but it is having a square. So by collecting like terms, since we want to make L the subject, that means we shall have to take this B squared on the other side. And since it is a plus, it will become a minus. So that gives us A minus B squared equaling to L squared. So that is our first step, collecting like terms. After you realize that we have L on one side, but that L is having a power. So our next step will be eliminating the power on L. So we shall take the square root on both sides of the equation. Since it is having a square, therefore we can eliminate the square by applying square root, but this one is done on both sides. So we apply the square root on A minus B squared and also square root on L squared, so that the square will cancel out with the square root, and therefore that will give us L as the square root of A minus B squared as our final expression. However, we have to note that we take the square root on both sides to get rid of the power 2 on L. What you do on the other side is what should be done on the other side, so that they are affected equally. So we have to take note of that. Let us go to our second example. In the second example, we are given that L equals to A squared N over P squared. So they want us to make A the subject of the equation. So since we are aiming at making A the subject, that means that we have to first remain with A squared. That is by taking n and p squared on the other side. However, if you look at our equation, it is a fractional equation. It has a fraction on this side. So the first step of handling such equations is to change the fractional equation to linear equation. How shall we do this? We shall multiply through by the denominator, which is p squared. So when we multiply through by p squared, we end up with L p squared equaling to n squared n. After that, we want to remain with a squared. So we have to divide by n throughout. So when we divide by n, this one reduces with this to end up with a squared. And therefore, a squared will be equivalent to LP squared over n. And now that we want a, therefore the remaining step is only to deal away with the square. How? By introducing square root on both sides. So that the square root will reduce the square and we remain with a, and then on this side, since it is affecting the wall, so it remains there. So that ends up with a equaling to the square root of LP squared over n as our final expression or the final equation. That is our second example. In the third example, we are given that a equals to pi r squared L plus pi r squared. So they want us to make r the subject of the formula. That is to say, from the given equation, which is the pi r squared L plus pi r squared, that means that since we want r the subject and it is appearing twice, therefore we first reduce the number of times it is appearing. How? By factorizing it out. So when we factorize out r squared, we end up with a equaling to r squared into pi L. Since we take away r squared, so here we remain with the pi L. And here we shall remain with only pi. So we end up with r squared into pi L plus pi. And now that we want r, therefore, we shall deal away with this bracket by dividing through. So if we divide it through by the bracket, we end up with r squared equaling to a over the bracket of pi L plus pi. And remember, our aim is to make r the subject. But at this step, we are having r squared, meaning we are only left with reducing the square. That is when we shall introduce the square root. So when we introduce the square root, but this has to be introducing the square root on both sides. So that the square root reduces the square to remain with r equaling to the square root of a over the bracket of pi L plus pi. So that is our final formula after making r the subject. Let us continue to look at more examples. Here we have example 4. In example 4, we are given that S equals to a half m into v squared minus u squared, but we are meant to make u the subject of the formula. If you look at the equation, u is having a power and it is in a bracket. This is it. So meaning that since what we want is already in a bracket, there is no need for us to open the brackets, but rather we shall take what is outside the bracket on the other side. However, we have a fraction, and therefore we shall eliminate the fraction by multiplying on both sides by 2. So that the 2 reduces the half and we remain with the m. So we shall have 2s equaling to m into v squared minus u squared. Still, we don't need to open brackets, but we shall rather divide by m on both sides, so that we have 2s over m equaling to v squared minus u squared. And now that we need to make u the subject, therefore we shall just take this one on the other side. So here we brought u squared on this side and it became a positive since it was a negative. Then we brought this one on the other side to become a negative since it was a positive. So we end up with u squared equaling to v squared minus 2s over m. Why didn't we just bring this the other side? Because we could remain with this as a negative still, but it is the same. If you take this one the other side, you get 2s over m minus v squared. And when you divide by negative, this one becomes a negative, the negative v squared becomes a positive, and you end up with this. So we just, to eliminate all that, we just bring this one the other side to become a positive. We bring this one this side to become a negative. And after now, we shall eliminate the power by introducing the root. So since it is a square, we shall bring a square root, which reduces the square, and we end up with u equaling to the square root of v squared minus 2s over m as our final formula after making u the subject. Otherwise, that has been how we handle non-linear equations involving higher powers. In our examples, we have been looking at numbers with power 2, but we can also have more powers. And how do we eliminate that? We just bring the equivalent roots to those powers. So in our next part, we shall be looking at how we handle equations with fractional powers. That is in our next video. Otherwise, I'm teacher Ivan from Wuna Educational Services. I hope to see you when we are all together for the next lesson. Please subscribe to our YouTube channels. We have many. Check on our TikTok account, Facebook, Instagram. Join our family so that we maneuver together through your academic journey as we guarantee your bright future through excellence. Otherwise, hope to see you next time. Bye-bye.